Let's take a look at change of variables, Jacobians. And first let's look at the definition of the Jacobian. If x is equal to g of uv and y is equal to h of uv, then the Jacobian of x and y with respect to u and v is given by this. Now the notation on the left side is just means the Jacobian. So partial of xy with respect to uv, and this is the determinant, not absolute value. Now let's see this with a problem. Okay, we got x is equal to u plus 3v, and y is equal to u minus v. The instructions say find a Jacobian for the indicated change of variables. You remember in Calc 1 where you had the u substitution? Well, this is a uv substitution, and this is just part of it. Well, our Jacobian going to be the determinant, and then we got the partial of x with respect to u. So take a partial derivative of x with respect to u, that give us 1. Then the partial of x with respect to b, well, that'd be 3. And then here the partial y with respect to u, so partial y with respect to u, that'd be 1. And then the partial y with respect to b, that'd be negative 1. Well, 1 times negative 1 minus 1 times 3 gives us negative 1 minus 3 gives us negative 4. Let's take a look at another one of those. We got x is equal to e to the u cosine v, and y is equal e to the u sine v. And we'll find Jacobian again. So we're going to have a determinant. Go back into our formula. Partial of x with respect to u. So I take a look at this. With respect to u, the cosine v will be a constant, and the derivative of e to the u is e to the u. So that gives us e to the u cosine v. And this is partial of x with respect to v. Well, the derivative of cosine is negative sine, so this become a negative e to the u sine v. This one's partial of y with respect to u. With respect to u, again, derivative of e to the u is e to the u, so this is e to the u sine v. And then the partial y with respect to v. Well, the derivative of sine is cosine, so this will be e to the u cosine v. So now, to find this derivative, we're going to take e to the u cosine v times e to the u cosine v minus then e to the u sine v times negative e to the u sine v. Well, if you got e to a power times e to a power, you add the exponents. It's kind of like x squared times x to the third. You add the exponents. So u plus u gives us 2u. And cosine times cosine gives us cosine squared v. Now here we got a negative negative, which gives us a positive. And e to the u times e to the u is e to the 2u. And sine times sine gives us sine squared v. Now they both have an e to the 2u, so I can factor that out, and that leaves us cosine squared v plus sine squared v, which cosine squared plus sine squared gives you 1. So this is e to the 2u times 1, or just e to the 2u. And that's our answer. Change of variables, Jacobian. Let me save this. Change of variables, Jacobian, page 01.pdf. Okay, let's look at our next problem. This is doesn't really match one in the book. I say 1 through 8. I should have got rid of those before I started the video, but I'll go ahead and get rid of that now. And let me fix this one. Okay. It says determine the change of variables and sketch the image S in the UV plane of the region R in the XY plane. Now again, there isn't one specifically like this in the book. The ones in the book give you what U and V are equal to, so they kind of make it a little bit too easy in that regard. So let's go ahead and take a look at this. And get some of my junk out of the way here. There we go. And okay, so we got this point right here, which is 0, 1, and then we got 1, 4. Should be right here. And we got 3, negative 1. Which should be right here. And then 4, 2. And if I had drawn this a little bit better, we would see it's a parallelogram. But we're dealing with this region here. Okay. Well, let's first find work with these 2 points. So we got 1, 4 and 4, 2. And we want to find the equation line that goes through these. Well, first thing we do is find m. So changing our y. So 2 minus 4 over 4 minus 1, which gives us negative 2/3. And we got y is equal to mx plus b. I'll choose this first point, 1, 4. Plug this in for x, this in for y. So we've got 4 is equal to negative 2/3 times 1 plus b. Take that over there, we got 4 plus 2/3 equals b, which is a mixed number. 4 times 3 is 12, plus 2 is 14, so we get 14/3 equals b. Now, our equation then is y is equal to m, which is negative 2/3 x, plus 14/3. Now, if I multiply everything by 3, we're going to get 3y is equal to negative 2x plus 14. And if I take negative 2x over, I'm going to get 2x plus 3y equals 14. Okay, so that's our first one. And that's going from here to here. Well, going from here to here will be the point 0, 1 and 3, negative 1. Now you're going to find something here. Subtract the y parts, negative 1 minus 1 and 3 minus 0, and we get negative 2/3. Now actually, it really doesn't matter what the b is on this. So if I were to set this up, this would be y is equal to mx plus b. So we got y is equal to negative 2/3 x plus b. And if I multiply everything by 3, I'm going to get 3y equals negative 2x plus 3b. And if I take that negative 2x over now, we get 2x plus 3y is equal to 3b. like I said, we don't really care about the b on this. Now you notice a pattern here. We got 2x plus 3y, we got 2x plus 3y. Which means for the lines going along here, both of these, it's going to be of the form, and this is where our substitution comes in. This will be the form u is equal to 2x plus 3y. And we don't worry about the number there. We just worry about this first part. Now after you find one, if you feel comfortable with your math, that's all you need. You don't need to do both of them. Well, let's find this line going this way. So between 4, 2 and 3, negative 1. Okay, so we got 4, 2 and 3, negative 1. And so then m is equal to, subtract your y part, so I got negative 1 minus 2 over 3 minus 4, which gives us negative 3 over negative 1, which gives us positive 3. Now again, we could care less about b, because the b is a number on the other side, and all that's going to change, it won't change the slope, it'll change where it passes through the y-axis. So we just said m was 3, so we got y is equal to 3x plus b. I could take the y over to the right side, so we got 3x minus y, and I could take the b over there, and you get negative b. But the important part is the 3x minus y. So going this other direction here, this right here is going to be, and I can't write it sideways like that, but use your imagination. This line here, usually they see it written out here to the side, but this one right here is going to be b is equal to 3x minus y. Okay, so that's our u and v we're going to be working with. Let me write that down. Let's see. U is equal to 2x plus 3y, and v is equal to 3x minus y. Okay. So let's scroll down here. If we list our points, what's our points? 1, 4, 0, 1, 3, negative 1, and 4, 2. And then we got our u, where u is equal to 2x plus 3y. And we got our v, which is 3x minus y. Well, if we plug this in for x, plug this in for y, we get 2 times 1, which is 2, 3 times 4, which is 12. So that gives us, what, 14? Let me double check that. 2, 12, 14, yeah. Now if I plug 1 and 4 in here, I get 3 minus 4, which is negative 1. I'm really good at messing up the basic math on this. But if I plug in 0 and 1, we get 2 times 0 is 0, 3 times 1 is 3, so that's 3. If I plug 0 and 1 in here, that's 3 times 0 is 0, minus 1. If I plug this point in, 3 and negative 1, 3 times 2 is 6, minus 3 is 3. And if I put 3 here, 3 times 3 is 9. Minus a minus becomes a positive, so that's 10. If I put 4 and 2 in here, 2 times 4 is 8, plus 6 is 14. And if I put 4 and 2 here, we got 12 minus 2, which is 10. So, with our transformation, our new points are going to be 14, negative 1, assuming I didn't make any basic math error. 3, negative 1, 3, 10, and 14, 10. Now let's go ahead and sketch these. Okay, so I got 14, negative 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, negative 1. Should be right there. 3, negative 1, which would be right there. 3, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3, 10 would be right there. And then 14, 10 would be right there. And that's our transformed area. So that's what we're working with there. Why is this beneficial? Well, if we set up our integral for this, not in this problem, but this would be our u-axis, and this would be our v-axis. If I looked at my u's, this would go from u is equal to 3 to u is equal to 14. And then v would go from negative 1 to v would go to 10. And it's a square, or a rectangle, I should say. It's a rectangle, so doing this setup is very easy and simplifies many integrals. Now the one I'm going to show is a pretty basic one that you could actually do a different way. But I was trying to make up my own without choosing a copyrighted one and put it out on the internet. And I wasn't having much luck. I spent quite a while on it. And I thought I'm just going to stick with the basics and you'll understand the concept, which is what's important. So let me go ahead and save this problem. And you notice we took a parallelogram and we mapped it to a rectangle. And let's take a look at our last problem. Now this is our formula for the change of variables for double integrals. Let R be a vertically or horizontally simple region in xy plane, and let S be a vertically or horizontally simple region in uv plane. Let T from S to R be given by T of uv is equal to xy equals G of uv H of uv, where G and H have continuous first partial derivatives. Assume that T is a one-to-one, except possibly on a boundary of S. You come up with results if it's not one-to-one. If F is if F is continuous in R and Jacobian is non-zero on S, then we can rewrite from this notation to this notation. Now this is where we change it to U's and V's. We have to put our Jacobian in here, and the S refers to like U is going from this to this, and V is going from this to this. And you see the du dv. So let's take a look at this problem. Okay. It says use change of variables to find the volume of the solid region lying below the surface Z is equal to f of xy and above the plane region R. Okay, so R is a region bounded by the parallelogram with vertices negative 2, 1, 2, 2, negative 3, negative 1, and 1, 0. Well, let's graph these and then figure out what our U and V are going to be substitution wise. Okay, so we got negative 2, 1, which is right there. 2, 2, which is right there. Negative 3, negative 1, which is right there. And 1, 0, which is right there. So let's see, this is negative 2, 1. This is 2, 2. This is negative 3, negative 1. And this one's 1, 0. and it's a parallelogram. Not that I can draw it, but it looks like that. Okay. Well, let's first look at these points up here. And do that over here. So we're going to look between -2, 1, and 2, 2. And we want to find the slope of the line that goes through those. Now we could care less about the b. So I got 2 minus 1, subtract our y's, and then subtract our x's. So we got 2 minus -2, which gives us 1/4. Now we're going to have y is equal to mx, and I'm not even going to put the b here because it really doesn't matter. And we got y is equal to 1/4 x. Multiply everything by 4, so we got 4y is equal to x, and take that 4y over, and we get x minus 4y, which means that dealing with this line that's going like this, this is going to be u is equal to x minus 4y. Okay, now let's go and look at this line going down like this. So we're going to have 2, 2, and we'll have 1, 0. And we'll find our slope, subtract our y parts, so 2 minus 0, and subtract our x's. So we got 2 minus 1, which 2 minus 0 is 2, 2 minus 1 is 1, so m is equal to 2. So we're going to have y is equal to mx, and we just found m was 2, so that, and take the y over, and we get 0 is equal to 2x minus y. So this will be v is equal to 2x minus y. Okay. Well, it's going to be our u substitutions. Let me write them down here. U is equal to x minus 4y, and v is equal to 2x minus y. Now, first off, let's go ahead and do our mapping. See what this changes to. So we're going to write down our points, which are -2, 1, 2, 2, and -3, -1, and 1, 0. And u is equal to x minus 4y, and v is equal to 2x minus y. So if I plug the -2 in for x and the 1 in for y, I get -2 minus 4 times 1. That gives me -6, I believe. If I plug -2 in here and 1 in here, I get -4 minus 1, -5. Plug 2 and 2 in. We get 2 minus 4 times 2. 4 times 2 is 8, so we get 2 minus 8, which is -6. 2 and 2 here, we get 2 times 2 is 4, minus 2 is 2. But plug in -3 and -1, we get -3, and -4 times -1 is a +4, so we got -3 plus 4, which is 1. And if I put a -3 and -1 here, I get -6 minus a minus 1, so -6 plus 1, or -5. And if I put 1, 0 in here, I get this is 1. And if I put 1, 0 here, I get this is 2. Well, let's sketch this and make sure it created a rectangle. Okay, so we got, and this is be our point, UV. So this would be -6, -5, -6, 2, 1, -5, and 1, 2. And this is our U, this is our V. So -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So that'd be that one. -6, 2 would be right there. 1, -5. So 1, -5 would be right there. And 1, 2 would be right there. Okay, so that's what it's changed to. And it's a rectangle, so that's good. Now, before we go on, let's note that this is going to be du dv. So the setup on this, we're going to have some other junk here, but we'll come back to that. We got du dv there, so this is going to be u equals, and u is going to going from -6 to u is equal to 2. So you're looking at your leftmost and your rightmost. And this one will be v, and v is going from, what's the lowest v value? -5? And it's going up to v is equal to 2. Okay, so that's going to be our limits that we put on our integration. Okay, so now we need to find our Jacobian. Now, what we've got here? We got u. Now we're going to work on our Jacobian. We got u is equal to x minus 4y, and we got v is equal to 2x minus y. Now what we want to get is we want to get x equals and y equals something. And we want to be in terms of u's and v's. Like we don't want the x to have a y in it. There's different ways you can do this. You could solve these as systems of equations and work it that way. You could solve this for y and then plug it into the other one. So let's do it that way. So I'm going to take negative y over here and take the v over, and we get that. So then we'll plug that into our other one, and we get u is equal to x minus 4 times y, which is 2x minus v. So we got x minus 4 times 2 is 8, so we got 8x. Negative 4 times negative v is a positive 4v, which gives us u minus 4v equals x minus 8x is negative 7x. So that gives us negative 1/7 u minus 4v equals x. Okay, so that's x equals part. We also need a y equals part. Well, we could do a similar thing in terms of, remember here we solved for y and then we plugged in another one. We could solve this for x and plug it into the other one. So we got u is equal to x minus 4y, and v is equal to 2x minus y. If I solve this for x, I take the negative 4y over, so we got u plus 4y equals x, and now we're going to plug that into our other one. So we got v is equal to 2 times x, so 2 times u plus 4y minus y. So we got 2 times u is 2u, 2 times 4y is 8y minus y. So we got v is equal to 2u plus 7y. And though it doesn't matter, I'll bring the 7y over here, so we got negative 7y, and we got 2u minus v. So then y is going to equal to negative 1/7 2u minus v. And let me write this down. So x equals negative 1/7 u minus 4v, and y is equal to negative 1/7 2u minus v. And we're out of room here, so let me save that. And do I have everything written down? Where's my u and v? u is equal to x minus v is equal to 2x minus y. Okay, u is equal to 4x minus 4y. V is equal to 2x minus y, and our integration is v is equal to negative 5 to v is equal to 2, and from u is equal to negative 6 to u is equal to 2. Okay. Still on number 4, so there's 4 continued. And we're still finding our Jacobian. We write down what x was. X is equal to negative 1/7 u minus 4v, and y is equal to negative 1/7 2u minus v. Now, you might find it easier to go ahead and multiply those through. So this would give us x is equal to negative 1/7 u plus 4/7 v. And this one will be negative 2/7 u plus 1/7 v. Now let me double check that. That looks right. Okay, so let's go look at our Jacobian. If I come up here, this is our formula for the Jacobian. So we're going to have the determinant. And just dropped the piece of paper, has all my information written on it. Okay, put that somewhere. Put it right there. So we got the determinant partial of x respect to u. So partial x respect to u would be negative 1/7. Partial x respect to v would be 4/7. Then down here, partial y respect to u would be negative 2/7. And partial y respect to v would be 1/7. Which would give us negative 1/7 times 1/7 minus negative 2/7 times 4/7, which gives us negative 1/49. Negative negative gives us positive. 2 times 4 is 8 over 49, which gives us 7/49, which gives us 1/7. So that's our Jacobian. Okay, now we're ready for our formula. And our what we're working with here is this 10xy, like that, and we're switching it. Let me see here what I wrote down. V is equal to negative 5 to v is equal to 2, and u is equal to negative 6 to u is equal to 2. And then we got our 10 here, and our x. Well, where did I write that down at? X is equal to negative 1/7 times u minus 4v, and that's just from up above, times y, and y we said was negative 1/7, times 2u minus v. Then times, and then our Jacobian, then our du dv. Now, where does that come at, the Jacobian? If I come up here, that's what this is right here. The Jacobian goes in there. Well, the 10 and the 1/7 I can put out in front. So that gives us 10/7. And negative 1/7 times negative 1/7 gives us a positive 1/49. So I can put that out in front. And then we've got v is equal to negative 5 to v is equal to 2. And u is equal to negative 6 to u is equal to 2. Now you don't see the true power of this uv substitution with this simple example I've done here. It really makes some problems come out very nice. I just wasn't good enough to make them up. Okay, so we're left with u minus 4v times 2u minus v. So u minus 4v times 2u minus v, du dv. Well, that gives us 10 over 49 times 7. Where's my calculator? I don't see it. That's not good. 49 times 7, 3, 6, 28, 343. Okay. V is equal to negative 5 to V is equal to 2. And U is equal to negative 6 to U is equal to 2. Okay, I'll multiply these together. U times 2U gives you 2U squared. U times negative V is negative UV. And negative 4 times 2 gives us negative 8 UV. So that gives us negative 9 UV. Negative 4V times negative V gives us a positive 4V squared. Du dV. And now we're ready to start taking our integral of this. Let me double check my math up there. Yeah. Okay, so work with the inner one. So this gives us 10 over 343 from V is equal to negative 5 to V is equal to 2. And this becomes, we'll add 1 to our power, divide by our new power, so that gives us 2/3 U to the third minus 9/2 U squared V plus 4UV squared. And then this is from U is equal to negative 6 to U is equal to 2 dV. These numbers may not come out too nice, since I made these up. Okay, so we'll plug 2 in for U. So we're going to have 2/3 times 2 to the third minus 9/2 times 2 squared times V plus 4 times 2 times V squared minus, now put parentheses here, and we got 2/3 times negative 6 to the third minus 9/2 negative 6 squared V plus 4 times negative 6 times V squared. And this will be dV. Okay, do a little bit of simplifying before we have to start a new page. Okay, V is equal to negative 5 to V is equal to 2. 2 to the third is 8, times 2 is 16, so that gives us 16/3 minus 2 squared is 4, and that reduces one of these, so that gives us minus 18V plus 4 times 2 is 8V squared minus negative 6 to the third $216. So that's negative 216, and that's divisible by 3. That goes into it's 72. 72 times 2. It'd be a miracle if I don't screw up this basic math here. So that gives us negative 144. Actually, I got a calculator on my computer here. Let me go ahead and use it. Be lazy. I say be lazy, but in real life, nobody wants you to sit there and do that by hand. They want you to use some kind of technology. By hand implies you could screw it up. So negative 6 to the third times 2/3. 2 divided by 3, math, enter. Negative 144. And then negative 9/2 and times 36, negative 162 V, and this is negative 24 V squared dV. Assuming I didn't make any basic math error. Let me write that down because I got to start a new page. So 10 over 343. V is equal to negative 5 to V is equal to 2. And then we'll have 16 thirds minus 18b plus 8b squared. And as I write it down, I'm going to use that, take that negative and flip the sign of everything in the second set of parentheses. So that becomes plus 144 plus 162v plus 24v squared dv. Okay, let me save that. Go. And let's continue with this problem. Okay, so we're now at 10 over 343. Even if I make a basic math error, I think you get the idea. 2 and 16 thirds minus 18v plus 8v squared plus 144 plus 162v plus 24v squared dv. Okay. Now we can combine some items here. Okay, so this will go from v equals negative 5 to v is equal to 2, and 16 thirds plus 144. 16 divided by 3 plus 144. Math, enter. 448 over 3. And then we got negative 18 plus 162. Gives us 144v. And we got 8 plus 24 gives us, I'm sure we screw this up, 32v squared dv. Okay, so now we're ready to take our next integral. So this becomes 448 over 3v plus 144 over 2v squared plus 32 over 3v to the third, from v is equal to negative 5 to v is equal to 2. And okay, I'm thinking if there's some easy way to do this. But now I'll plug 2 in for v, so I got 448 thirds times 2 plus 144 divided by 2 gives you 72, so 72 times 2 squared plus 32 over 3 times 2 to the third minus, I'll put parentheses around this, and we'll have 448 over 3 times negative 5 plus 144, oops, that's 72. Plus 72 times negative 5 squared plus 32 over 3 negative 5 to the third. Now let's see if I can type that in without screwing it up. So we've got 10 divided by 343. Beginning parentheses, 448 divided by 3 times 2 plus 72 times 2 squared, which is 4, plus 32 divided by 3 times 2 to the third, which is 8, then minus, and we have to put a parentheses around all this, so then we've got 448 divided by 3 times negative 5 plus 72 times negative 5 squared, which is 25, plus 32 divided by 3 times Negative 125. Enter. And that's approximately 27.76 for our volume. Or we could do math enter and get the exact value. So that'd be 13. There we go. 1360 over 49. So let me go ahead and save that. Those are interesting problems. Kind of fun, really. There we go. Especially the more complex ones that's in the book. It's kind of neat to see them drop away to something very simple. It's like, oh, that's too cool. Okay, so I'm going to go ahead and save this.